Hi everyone, welcome to my YouTube channel. Today we will be solving the question of removing nth node from the end of a linked list. So here we are given this linked list where head points to node 1 and we are given a variable n equal to 2, which means that we have to remove the second node from this linked list. So the second node from the end is node 4 and we have to remove it. So after removing, our linked list is going to be this 3 and 5. So let's see how we can solve this question. Any node from a linked list, what we are going to need, think about it. So we are going to need a previous reference. So to remove this node 4, we are going to need the previous reference which points to node 4. So node 3 points to node 4 and we can simply update the previous reference by pointing the previous dot next to previous dot next to next, and this way we can remove this node 4 and we will be done. Now what if we want to remove the head node? So let's say in our given input linked list the value of input n is 5. So in this case we have to remove the head, and as we just saw, we are going to need a previous node to remove any given node from a linked list, and this head node, it doesn't have any previous node which points to head. So this is a classic example of using dummy nodes. So what we are going to do is we are going to create a dummy node like this: 2, 3, 4 and 5. So one thing is clear, that we are going to need dummy nodes to solve this problem. So how can we solve this problem? So this problem can be solved using slow and fast pointers. So how are we going to use slow and fast pointers to solve this problem? So let's see. So let me draw this linked list again. 1, 2, 3, 4 and 5. So what we need is, we need a state where fast pointer becomes null, because fast pointer is faster, so that's why it should be ahead of the slow pointer. And since we need to remove the node 4, my slow pointer should be somewhere here. It should be the previous node, and since n is equal to 2, as you can see, the number of nodes between the slow and fast pointers is also equal to n, and the number of iterations between slow and fast is n plus 1. So now as you can see that we need a gap of n plus 1 pointers between slow and fast pointers to remove the nth node from the end of a linked list. So what we are going to do is we're going to initialize our slow pointer to the dummy node. So let me first draw this linked list again, and this dummy node here, this is dummy, and my slow pointer is initially at dummy, and my fast pointer is also at dummy. So what I have to do is I need to increment the fast pointer till the distance between slow and fast pointer is n plus 1. So I have to keep incrementing fast. So after n plus 1 iterations, my fast pointer is going to be at node 3, and now as you can see, the number of nodes is 2 and number of iterations is 3 between slow and fast pointers. And now I can increment slow and fast pointers equally by one step till my fast pointer reaches the null node. So when my fast pointer reaches the null node, my slow pointer is going to be just before the nth node. So let me draw this again to understand this better. 3, 4 and 5. So my fast pointer will reach the null node in 3 iterations. So, and my slow pointer after 3 iterations, where it is going to be? It is going to be at node 3. As you can see, from dummy to 1 it's 1, and then 2, 3. So it would be at node 3, and my fast pointer will reach the null node, and we have to delete the nth node from the end. So I can simply update my slow dot next equal to slow dot next dot next. In this case, slow dot next can also be null. So if slow dot next is equal to null, we can simply set slow dot next as null, and if it is not null, then it would be slow dot next dot next. I hope this made sense. And now let's have a look at the code implementation of this question. So now let's have a look at the code implementation of this problem. So we have to implement this function remove nth from end, and the given input is the head of the linked list and the integer n. So here from the constraints, n is greater than equal to 1 and less than equal to size. So we don't need to worry if n is greater than size. So here, as we discussed, what we are going to need is 2 pointers, slow and fast, and we also need a dummy node. So let's create a dummy node first. So here I have this node dummy equal to new list node -1 and dummy dot next equal to head, and now I can create my slow and fast pointers. Slow equal to head, sorry, it's would be equal to dummy, and list node fast is equal to dummy. And now we have to increment the fast pointer by n+1 iterations. So what we can do is can use a for loop I less than equal to n+1 I plus plus, and we can increment fast equal to fast dot next, and if at any stage fast becomes equal to null, then we can simply break out of the for loop. So after we finish the for loop, now we have to increment both the slow and fast pointers till fast reaches null. So it can also reach null here as well. So in our next loop, what we are going to do is we have to do a check on fast pointer itself. So if fast is not null, then only we do these iterations. If fast is null already, then we can simply update the slow pointer. So here what we are going to do is we have to increment slow and fast pointer by 1 step, and once this while loop finishes, which means fast becomes equal to null, now slow pointer is just before the node which is going to be deleted. So I have to update my slow dot next equal to slow dot next dot next, but here what could happen is slow dot next could be null. So I can add a check here. If slow dot next is not equal to null, then set it to slow dot next dot next, and if it is null, then simply set slow dot next to null. And finally what I can return is I can simply return dummy dot next, which would be the head of the modified list. So let's try to run it, and yeah, it works, which is good. Thank you for watching, and I'll see you in the next video.